Listen to me carefully. So what it says in the first question. The confusion arises when now, like we have a habit of like, conserving the current just before the chapter in that isn't it? But the concept is what? The flux should be same, isn't it? That is flux is like there's a multiple condition which we can which are there's a also we've seen like this like conductor of is there. Like, it has some sort of right. So we just like and which is a medium in between them, right? So the current is in this circuit is I. So what the flux is what? Flux is simply L into I, isn't it? And L is what? For a solenoid. Like it depends on the mu as well, like isn't it? You know this formula, like self of a solenoid. Like I current flow through the what is different to that one? Mu not I into L into pi r square. Mu not N I in L r square. Right? That is equal to what? L into I. L is what? Mu not N square L pi r square, isn't it? This I know. For a time, like I can calculate. But when the medium changes, it will become what? Mu equal to what? Mu equal to mu r. Then L will be what? L will be equal to mu not mu r N square L pi r square, isn't it? So L will be mu not mu r N square L pi r square. Okay, fine. But the so you can let's say at equal to zero, like within the medium directly. So what I can write? Then I at equal to zero plus equal to zero should not be equal to I at equal to zero plus. We'll just insert an iron core between them. Right? And the medium change instantly, right? So according to adjust the flux, like flux is what initially L into I, right? So that should match with the what? L dash into I dash, isn't it? Because that thing should match. Not the current should match always, isn't it? Concept is what? Flux should match, no, isn't it? So the idea is it, I can just take an example of it. Let's say we have a solenoid and initially there is a current flowing through this one is let's say 9 ampere. Okay? The solution like now we inserted iron core instantly, right? Very instantly. So there's a you can imagine that the current is just 9 ampere equal to zero. Right? Let the inserted iron core that is mu equal to 2 of this medium. So inductance is initially L. It will change to what? 2L now. Directly. Let's say mu equal to 3 square. Fine. It is simply 3L, isn't it? Because linear relation with the mu bar, no? Mu bar is 3. Fine. To maintain the flux, initially the flux should match, right? Flux content is in the inductor. That is the definition. So, like, 9 should be equal to 3L and I equal to 0 plus. Current will change instantly, isn't it? I equal to 0 plus will be what? 3, isn't it? Correct. So, as far as this question is concerned, this is a similar concept. So what it is, initially there is a capacitance C naught and inductance L naught. This L1 is what? L1 is simply L naught and L2 is what? L2L. Initially this is the circuit. Initially switch S2 is closed, this one was closed, and this one was open. So what will happen? So current will flow in the circuit. That is I is equal to E by R is 9. So I will be what? 9 ampere. What we have done, we have just after that, just open the switch and close that switch. Isn't it? So what will happen? This is the work. Simple capacitor out. Just initially moved that mentioned the question. And then it out there. But it is also written out there at well known, right? What I know, of course, you have a concept what? The flux can't change instantly, right? Because current going to initially there is no current in between. There's no current in between. So what will happen? You maintain the flux. Like from this it should pass 9 ampere to maintain, right? Isn't it? But through this wire it can't pass anything because initially it has zero. So what will happen is this concept is what flux should match. A different current will flow at equal to zero plus, isn't it? So at equal to zero plus, what will happen? If different current will flow in the cell. Let's call it I. The initial flux is what? Like 9 into L naught. No? Then that should be equal to what? Let's say I conditional at equal to zero plus. As I have written it. It should be equal to what? L naught into I plus 2 L naught into Y. Isn't it? Then I can write what? I will be equal to what? 3 ampere. The scenario is like what? Scenario is like on all there is series as well. Scenario is what? Like there's a capacitor, there's a slot. It's connected with a two inductors. The common inductor out there. That is what? 3 L naught. No? Current is what equal, at equal to 0. I equal to 3 ampere in there. Now it is what? It is simply now LC oscillation. Got it? LC oscillation will be there. I have to find out what? At which time the rate of storage of energy of capacitor will be maximum. Okay, fine. So let's say this is condition is what? At t equal to 0 plus. So let us just analyze. Let us analyze because in t equal to 0 there is no charge, right? 0 charge. So what will happen at any time? Time. And this is t equal to 0 plus condition, na? Like current is flow with 3 amp. Then so what will happen at t equal to t? There will be some charge on the capacitor as well. There will be some different current in the reactor. That is the energy transfer to the capacitor, right? Energy transfer to the generator as well. Let's say this is C naught and this is what? L. 3 L naught. Right? Let's the current in this branch is let's say this is I. So let's say this is I naught of course. So what I can write the K will look like the what? Like this is plus it is minus. So I will write what? Minus 3 L naught. Hello, comfortable? Di by dt plus Q by C equal to 0. This I can write for sure. Although it's like we have to find out what? We have to find out just a second. Okay. Yeah, fine. Actually there's no need to write this equation as well. Because what I know is at t equal to 0 plus I is what? 3 ampere, na? And Q is what? 0 ampere. Sorry, 0 coulomb. Right, this I know. So let us assume that because what I know Q is what? Q is simply Q naught times 2 plus 5. You know what? At initially, like there is no charge on the capacitor, right? No charge on the capacitor. So of course 5 should be 0, right? Yeah, of course 5 will be 0 and 5. Its current is 3 ampere. Right. So I is what? Not omega. Cos omega t plus 5. Because this is a general equation which I have derived. Cos omega t plus 5. This is a I value, right? I can directly write as what? I know like equal to 0 plus it will be Q naught omega cos 5, isn't it? And that is equal to what? That should be equal to 3 amperes. And what I know, omega is simply what? 1 by root L. Like and 5 will be what? Because t equal to 0, you not find by 0, 5 will be 0 or 5. So of course 5 can't be what? 5, right? Because then this will become negative. So I have 5 as 0. I obtain what? Q naught into omega is equal to. I have to calculate what? I have to calculate that current particularly when the storage rate of energy stored in the capacitor will be maximum. Okay, fine. That's completely fine. Rate of storage of energy in the capacitor is what? D by dt of that energy. Energy is what? Is the power itself. Power plus capacitor. That should be 0, no? Because this got maximized. Power across the capacitor got maximized, no? See the wrong statement. Power across the rate of storage of energy across the capacitor. So there should be. And what is PC? PC is what? Q by C into I. Isn't it? That should be by dt equal to 0. And what is charge on the capacitor? It is simply Q naught omega t, Q naught sin omega t upon C into I d by dt of that should be equal to what? 0 itself. Fine. If we just differentiate, let's just write it as Q as well. So not separate this one. So what I can write, I can simply write as d by dt of IQ equal to 0. But IQ is constant, isn't it? IQ is constant of a person, isn't it? Right? So C is constant, the capacitor. It is just different d by dt into Q. Just dq by dt into I. Basically put up proof. Fine. So what I can write di by dt into Q plus I square equal to 0. And what I know, Q is what? Q is simply Q naught sin omega t, no? Isn't it? Just put the value. Q is what? Q is simply Q naught sin omega t. Let's differentiate this in one more. So I is what? Q naught omega sin omega t. Sorry, cos omega t. Q naught omega cos omega. Differentiate once more. So d by dt will be what? Omega square sin omega t. Then I will put what? Is the values I will put. So minus Q naught omega square sin omega t. And Q is what? Q naught sin omega t plus I square. I is what? Like this will cancel. So it will be equal to Q naught square omega square cos square omega t. Fine. So this thing and this thing will cancel. I have what? Tan is equal to cos square and tan omega t equal to 1. When tan omega t is 1, then what it means? Omega t should be equal to 1. 5 by 4. No? Okay. Omega t 5 by 4. No? Got it? So the current will be what? Current will be simply Q naught omega into what? Uh, cos 5 by 4. And Q naught omega is what? Maximum charge, maximum current, right? So that is 3, isn't it? So that I is what? At that instant. That instant will what? 3 by root 2. Something now. And this concept, this person is very important again. Of course. That's why I'm here. Huh? Fine. Read this problem. Correct. Flux should be same. Read this problem. Fine. What this question says is we have a horizontal like railroad track, right? We have a horizontal. Bear with me. So initially, like this is sorted. You can win the question. This is sorted. Just read carefully. First, what it says. Horizontal railroad of like track of length 1 meter is like this is the meter, and resistance per unit length is 5 ohm per meter. It is given a velocity that is v naught out there, right? So of course there will be some magnetic force because of that. It says it stop after discovering that particular reaching that end, right? Become v finally. Right. So what? So like this has a resistance of it's smaller and this is given as like what 10 ohms out there, and this is a this particular conducting rod has resistance per unit length out there, fine. So you can easily visualize as the time will pass, this will it's smooth resistance will decrease in the circuit, isn't it? Resistance will decrease because like initially this is total length is 112 meter and then it will decrease to some extent, isn't it? So like that's at any time t that will happen. Of course, I would quite at any time I will write the force equation, Evil equation in the loop, and I will simply able to solve the problem, isn't it? So let's say at any time t, this is our situation. It is our end out there, and it's moved at distance x. And let's say the velocity is what? Velocity this simple battery will be there. Velocity is v, and there will be some negative force out there in the backward direction. That is from current will be in this direction, right? So the resistance of it's smaller, and so this is the current in do that. That's simple way to start, right? Fine, fine. And this, this length is x, and this will be 1 minus x. This will be again what? 1 minus x. So what I can write, current will be equal to what? Current in the loop, E by R, and E is what? BV in at that time. Resistance is what? 1 minus x plus 1 minus x into 5 plus what? Small r, isn't it? Small r is 10. Small r is 20. Sorry, 10. Got it. And one more thing. Uh, this length is L and L is 0.5. Okay? This is given. Now just be very careful. Like this is B and this L is at 0.5. Okay? So B is what? Just to okay, fine. We can put the values in the last. So B L 1. This is like uh, R is again 10, 10 plus 10 minus 10x. Okay, the second part. So this value of current out there. So current is BVL BVL upon 20 minus 10x. Okay. I is BVL upon 20 minus 10x out there. Got it? No? Then I will write what minus Fm equal to on this particular M dV by d M Mn to A. Isn't it? And A is what? V dV by dx. Isn't it? And Fm is what? Minus ILB. Minus ILB equal to M V dV by dx. Find this clear? And I is what? Simply this value. Just put the values out there. I have to do. So minus B square L square V upon 20 minus 10x. That should be equal to what? MV dV by dx. Got it? This is the equation. Of course, you can see V and V got cancelled, isn't it? V cancel. Now I have minus B square L square upon 20 minus 10x. That should be equal to into dx is equal to dv. M dv, right? Then I know what at x equal to 0 velocity is what? V naught, isn't it? And x equal to V, it is 0 and at x equal to 1 meter, isn't it? I have to solve for the V naught. Now just put the limits out there. And B was I guess 20 and B was it is like minus 400 and into L it is 1 by 4 and integration from 0 to 1 dx upon I can take out the 10 as common 2 minus x and this is equal to what? Minus M V naught. So it is seems like this concept 10 log of minus x 1 minus 1 from 0 to 1 equal to mv naught and mass is 100 grams but the point 1. So it is like 100 the negative sign ln 1 minus what? Ln 2. Right up minus with the negative sign. That becomes 100. Ln 2 is the v naught value. Then v naught is what? 0.7. So like v naught will come out to be what? 70 meter per second. Got it? Again, it's a good question, isn't it? Not like that's boring a real problem like repetitive, isn't it? Quite modified later, isn't it?